this question in the probability portion of the Greenbook is called hopping rabbits. It says a rabbit sits at the bottom of a staircase with n stairs. A rabbit can hop up only one or two stairs at a time. How many different ways are there for the rabbit to ascend to the top of the stairs? So for questions that say like n stairs, where can be any number, it's hard to imagine. You're better off starting off with one stair, two stair, three stairs, for example, so you can kind of understand the question in a better manner. And with this one stair, two stairs, like easily digestible solution, you can build a relation and then find your answer for n stairs. So let's start off with one stair. How many different ways are there for the rabbit to get to the top of these stairs? Well, what are its options? It can only go up and chose to do a one stair hop. It can't do a two stair hop because it'll miss, right? It's gonna like, whoop, I don't know. It can't two stair hop when it's one stair before the ending. Okay. This sequence is one, as in this. It took a one stair hop and that's it. Okay. Now what about a two stair solution? Well, the rabbit can either do two singular one stair hops like this, or it can do a singular two stair hop. And the sequence here is 1, 1, and 2. Okay. Now what about for three stairs? The argument here for this question, and the way we're going to solve this question more generally, is you have to see that to get to staircase 3, all you have to do is look at all the ways you got to staircase number 2 and then just jump up by 1, right? Because if you're at staircase 2 and you do a singular 1 level jump, you'll be at 3, right? And then look at all the ways you end up at staircase 1. So in this case, it's just 1 stairs, like a 1 stair sequence. And then do a 2 stair hop to get to the top. So again, it's to get to staircase 3, it's all the ways we got to staircase number 2 plus a 1 stair hop. Plus is misleading. I would just say append a 1 stair hop to the sequences. And then all the ways we got to staircase number 1, and then you append a 2 stair hop to that to get to staircase number 3. Because if you're at staircase 1 and you jump up by 2, you'll get to the top. If you're at staircase 2, jump up by 1, you'll get to the top as well. So we're saying staircase number 3, the solution is all the ways we got to staircase number 2, whatever that may be, and then a 1 stair hop at the end. Plus the length of the sequences, so not the number of ways we got to staircase 1, whatever that may be, and then a 2 stair hop to get to the top. So what does that look like? That looks like, well, sequence 2 was represented here with 1, 1, and 2. And then we're saying we append a 1 to the front of that sequence, or to the end of that sequence. And that represents the first portion of our way to get to staircase number 3. And then we look at all the ways we got to staircase number 1. What was that? It was just a 1. And then we append a 2. As you can see, the number of ways for the portion that represents f of 2, right? And this represents f of 1, right? Because we're saying, oh, all the ways we got to staircase number 1 and append a 2. But this represents f of 1 in this portion, and that represents f of 2 in this portion, right? As you can see, the lengths remain the same. In the original f of 2, there was 2 ways to get to staircase number 2. And once we appended a 1 to each solution for f of 2 portion of f of 3, it was still 2 sequences, but for all those sequences, we just appended a 1 to the front to the end of them. So what we're saying is f of 3 is really just f of 2 plus f of 1, right? Because f of 1 had a length of 1, right? Because it was just one, there was one sequence. How many different ways? There was one different way to get there. And f of 2 had 2 different ways to get there. And we saw the answer for f of 3, there's three ways to get to the top. So f of 3 equals f of 2 plus f of 1. Okay, so we can say generally f of n equals f of n minus 1 plus f of n minus 2. Let's verify that before we make a general claim. Let's look at four-stair solution. So 4 stairs. We're saying everywhere we got the staircase number 3, whatever those sequences were, then jump up by 1 to get to the top, plus all the ways we got the staircase number 2, and then jump up by 2. You're going to get some number of sequences from the 3 portion and the 2 portion. You add up the number of ways you got to each, like for each portion, and that's your answer. So our claim is f of 4 equals f of 3 plus f of 2. Let's see if that's the case. So f of 3 portion was, we're saying all the ways we got the staircase number 3, and then append a 1 to each sequence, plus all the ways we got the staircase number 2, and then append a 2 to all of those. Well, f of 3, we said it was 1, 1, 1, 1, 2, and 2, 1. And for f of 2, it was 1, 1, and 2, as you can see here. Okay? We're saying we're going to append a 1 to all of these ones, because we're 1 stair before the ending. So all we have to do is do one more hop. And then, when we ended up at staircase number 2, there's still 2 stairs between us and the destination, so we're just trying to do a 2-stair hop to get to the end of that. Okay? And so we're saying that f of 4 has 6 ways to get to the top, and it's these 2. It's these 6, actually. And this is f of 3's portion. That's f of 2's portion. So the lengths of this portion and f of 3's length are the exact same. The length of this portion of the answer and the length of the f of 2 are the exact same, because we have the same number of sequences, but we just add stuff to each sequence. So it's still the same number of ways for each part. So we're saying that f of 4 really is f of 3 plus f of 2. And so, again, f of n generally is f of n minus 1 plus f of n minus 2. But we have to have a base case, for like people that know recursion, the base case, because we can't start off like f of 2, because f of 1, for example, let's say we use this formula for it, we're going to end up with f of 0 plus f of negative 1, which makes no sense. And for f of 2 as well, we're going to have f of 0 in the solution. It'll be f of 2 equals f of 1 plus f of 0, which you don't have. So we have to say, okay, we have to solve this part manually ourselves and say f of 1 equals 1 and f of 2 equals 2, and then f of n is that. And that's our like 3-part function for the answer. So f of 2 equals 2, not 0. I don't know why I read that. Yeah. And so that's our answer for this question.